Exercise 3A, question number 1. So Q1 equal 46, Q3 equal 68. So this is Q1, this is Q3, so this is 46, 48. So interquartile range is going to be IQR is 68 minus 46. So it's going to be 22. So this distance is 22. Then we want to find 1.5 times of 22 distance. So this is going to be 22 plus 0.5, half of 22, 11. That is going to be 33. So now I need to add this amount to here. So I want to find 33 away and 33 away point from these points. So this is going to be 68 minus 33. So 68 plus 33. So that is going to be 101. So this is 101. And the other one is 46 minus 33. When you minus this one, this is going to be 1. So this point is 13. So any data from this point onwards, they are extreme values, extremes. So upper boundary for extreme values, that is Q3 plus 1.5 times IQR. So Q3 is 68 plus 1.5 times IQR is 22. So total is going to be 101. Lower boundary for extreme values, that is Q1 minus 1.5 IQR. Q1 is 46 minus 1 point times 23, that is going to be 13. Question number 2, males and females. So males, it's going to be lower. Q1 is 260 and so it is going to be 400, and Q3 is going to be 580, and female it is going to be 260, and Q3 it is going to be 340. So IQR is so this range is 580 minus, so this is going to be 180, and this is 240 plus 40, this is 80. So IQR is 80, and so it is 1.1 times interquartile range. So I want to add to get this boundary to 180 away, and this is also 180 down. So 580 minus plus 180. So this value is 580 plus 180, 760, and this is going to be 400 minus 180, 220. This is one boundary. For this one, 340 plus another 80, because 1 times it means 420. So 260 minus 80. So it is going to be 180. So this is for female. Now, so male we have 400, 260, 550, and 640. When we look at okay, upper and I think 260, 550, 640. So when you look at for males, all the value inside 220 to 720, all the values in between here. So 260 here, 400 here, 550 somewhere, 640 somewhere. So there is no outliers. Now for this one, 170, 300, 340, 440. So there is 170. So there are two outliers, because when you take 180 to 420, so 170 out of this region and 440 out of region. So there are two outliers, 170 and 440. For males, right, IQR is 580 minus 400, that is 180. Upper limit for extreme values is 580 plus 180, that is 760. Lower limit for extreme values is 400 minus 180, that is 220. So outliers is less than less than 120, and outliers greater than 760. Hence, there are no outliers for males. The same thing. IQR is 342.60 is 80. So upper limit for extremes values is 340 plus 80, which is 420. Lower limit for extreme value is 260 minus 80, 180. Because this is defined with one standard deviation. Q3 plus 1 times IQR. This is Q1 minus 1 times IQR. Now, so outliers either less than 120 or either greater than 420, 180. Hence, there are two outliers. They are 170 and 440. Question number 3. So this is work with the standard deviation. So x bar is given 6.1 kg, and the variance sigma square OV is given 4.2. Sigma is sigma is going to be square root 4.2. So this value is going to be, I will leave as it is. So it's square root of 4.2. So then upper limit for extreme values is x bar plus 2 times sigma. Now it is going with not the upper quartile x bar plus this distance is 2 times sigma. So x bar is 6.1 here and 2 times sigma. So this distance is going to be this is 6.1 x bar, and this distance is going to be 2 times sigma 4.2, 2 times sigma this side and 2 times sigma to this side, 2 times 4.2. So we need to find those two values. So this is upper, this is lower. So upper is x bar 6.1 plus 2 times square root 4.2. So this value is going to be 10.2. So this is 10.2. See, this is upper, this is 10.2, and this is lower limit for extreme values equal x bar minus 2 sigma. X bar is 6.1 minus 2 times 4.2. This is going to be 2. So this value is 2. Now how many values we have? 2.4, 10.1, 3.7, and 11.5. So 2.4 inside it between 2 to 10.2. So it is inside 10.1 inside. The 10.2 is the answer. 3.7 inside. 11.5 is outside. Right? You can't put into this interval. So 11.5 hence we'll write hence 10.2 is the outlier. Sorry, 11.5. So it is out of range. 11.5 this value. Part B, what is the smallest and the largest masses that can Arctic fox can be without being an outlier? So basically, what is the minimum and the maximum value they are asking? So it means we can write the values should be it is in between 2 and 10.2. Hence lowest and highest are 2 and 10.2. Question number 4. Some data is given. The data set, there are 9 data values. So addition of this one 92 and summation x square is 1428. Now the first one is find the mean and the standard deviation. So mean x bar is summation x over n. So this is going to be 92 divided by 90. So this is going to be 10.5 to approximate. Then the sigma is square root. So summation x over n, and write the same thing again. And this is x square and bracket, and this is a square. So then this is going to be summation x square 1428 divided by 9. This is x bar basically. This is equal to x bar 10.2 square, because summation x over n is x bar. X bar is 10.2. So this value is equal to 7.36. So sigma is 7.36. Then part B. So in an outlier observation with lies plus or minus 2 standard deviation from the mean, and the data value is given 30. So we want to show that this is a outlier. So basically they want this is x bar and 2 this is x bar. Then they want 2 sigmas away these values, and 2 sigma less than this x bar. So x bar is 10.2. Then this value is going to be 10.2 plus 2 times sigma is 7.36. So this value is going to be 10.2 minus 2 times 7.36, 2 times. So upper limit for extreme values equal 10.2. So x bar plus 2 sigma. So 10.2 plus 2 times 7.36. This is going to be 24.9. And limit, lower limit. So lower limit for x bar minus 2 sigma. So 10.2 minus 2 times 7.36. So this value is going to be minus 4.50. Now this is 24 minus 4.50, and this is 30. This value is going to be 24.9. 24.9. 30 is an outlier as 30 is greater than 24.9. Now, part C in this question suggests a reason why this age could be legitimate data value. So we are discussing about a data set about the age. Now, age of the age of a people at children's party. So this is a legitimate value because it is still a possible value. This value is still a possible value. Possible value. But if it is 130, no, it's not possible. It can't be age of a human. It could be a age of an elder person in the party. Part D, we want to clean this data set. So we have to drop this data set. Not data set, it is data value. So we have summation x equal 92. Then the new group value is summation x going to be, let's say, x1 or x summation x new is 92 minus 30, 62. Now new x bar new is 62 minus now number of people is going to be 8. In new is 8. So 62 divided by 8, this is 7.75. Now summation x square new x square is we want 1428 minus 30 square, which is going to be 528. Then sigma new is again summation x new square over sum n new minus summation x new over n new square. That is going to be 529 over 8 minus 7.75 square. So this value is going to be 2.44. I rather like 9 minus 1 because we took the 30 data value out because it's an outlier. So we cleanse the data.